Welcome to solverfy.
All right, for organic reactions, there are many different types of reactions that can happen. We're going to look at a few that are pretty common and what our goals are, right? So if we are trying to make an alkane as a product, typically we'll have something that is already an alkene, okay? So a double bond, or an alkyne, possibly it's a triple bond. Okay? So our goal there, if we're just simply trying to make it a single bond, an alkane, okay, it is possible to add hydrogen, H2. Sometimes this will need a catalyst, and that's totally fine. Okay, and what we see is that this H2 compound, okay, reacts and we end up with a single bond, okay, between our carbons because we add an additional hydrogen onto each carbon to give us that alkane, which is our single bond. Okay. All right, if we are trying to halogenate or add a halogen, so chlorine, bromine, iodine, fluorine, to a compound, it's going to be the same kind of idea here. So it's possible to take something, even something like CH4, methane, and if we add a halogen, now remember halogens are diatomic, so they'll also be that subscript of 2 there, okay? What we will see is that one of our bromine atoms will actually replace or substitute, it's a substitution reaction, for a hydrogen. So we'll end up replacing one of those with a bromine, which removes that hydrogen and leaves us with another bromine. So we end up with HBr, hydrogen bromide, as our other product. All right, another option is adding multiple halogens to a compound. Right, now if we do this, again, kind of like our first example, we're going to see that many times we'll have a double bond in the compound already. Right, so if we have a double bond in there, if we look at this alkene, okay, double bond, we can use the same type of reaction that we did with our halogenation previously, okay, but what we'll see is that it actually just is an addition reaction, so the bromines attach and leave a single bond as our product. So I'm going to put it down here. So what we really end up with is our H2Br with that first carbon, okay? Now single bonded to our CHBr, okay? So hydrogen and bromine are connected to the second carbon, okay? And then our CH3 third carbon stays as is because that was already single bonded with its hydrogens. Right? Another thing we can look for is fully halogenating, okay? So sometimes we might have a compound that already has some halogens with it, and we want to fully halogenate that compound. Right? So if you think about carbon, we have hydrogen and 3 bromines surrounding that carbon, all single bonded. So we can substitute another halogen in there, whether it's another bromine or something, okay, by using HBr in this case, or hydrogen bromide. Oh, I'm sorry. Let's back that up. We're going to use Br2. So if we use Br2 there, okay, same idea with our substitution as what we did before. So we're going to remove that hydrogen and fully brominate or fully halogenate that carbon. Okay, substitute that hydrogen out and form hydrogen bromide as a product. All right, last 2. Okay, we can take a benzene ring. Okay, so if we have a benzene ring, remember benzene is our 6-carbon compound, does have those double bonds, which we can also indicate with that circle. Okay, if we want to halogenate a benzene, it's the same idea as our substitution reactions that we looked at. Okay, so remember on benzene, there are carbons at each point with hydrogens attached in whatever number. It'll be 1 hydrogen at each one. So it's really C6H6 when it starts. Okay, typical substitution reaction. So the double bonds stay as is. We're going to halogenate 1, which removes one of those, substitutes one of those hydrogens. So we end up with hydrogen chloride as our other product. Okay. And finally, When we look at saturation, or how many double bonds, triple bonds, single bonds there are, okay, if we start with something that is an alkyne or a triple bonded compound, right, with a limited amount of hydrogen, okay, we can form an alkene instead. Okay, so in doing that, right, we're adding those hydrogens in, okay, which means around that carbon now we have the double bond and the two hydrogens, whereas in the beginning we started with the triple bond and only one hydrogen. Okay, so that's another addition reaction that we have there.